way the parameters get passed from one screen to another is through the URL bar, the address bar at the top. You've just seen that, you know, X equals this parameter, Y equals that parameter stuff at the very top of the address bar. That's editable. So conceivably, somebody, probably a hacker, could go in there and modify those and cause an unsupported event or event condition combination to be injected, if you will, into the system. So we need some way of forcing those out into the open so that we can at least have a discussion with people about what should happen in those circumstances. And the state transition table allows us to do that. The way that it does that is that you take all defined states, which you can see here. This is the list of the defined states. So we have 1, 2, 3, 4, 5, 6 defined states, right? And then we have a list of all of the unique event or event condition pairs defined here. So click link, that's one, add to cart, continue shopping. Those are 3 events for which a condition never applies. So there's no condition specified there. Similar checkout. Now, login is a single event that has 2 potential conditions that can apply to it, bad and good. All right, so now our list is up to 6 because they're unique. Where Steve's getting his exercise here. Keep having a screen going blank here. Now, purchase, similarly, bad and good, right? Those are conditions that can apply. And then we get abandon, resume shopping, and go elsewhere. So we've got 1, 2, 3, 4, 6, 8, and then 3 for 11. Okay. So, excuse me, there are 6 times 11, or 66 possible combinations of states with events or event condition pairs, right? So what we do is we define a table that has 66 rows in it, and we methodically generate all of the combinations of events with, of states with event condition pairs. As you can see, excerpt here, we have browsing with click link all the way through browsing and go elsewhere, right? So that's the combination of this guy, browsing state, with this, and everything in between shown here, right? Now, based on the diagram, we can then populate the action and new state columns, this guy here and this guy here. Basically, if there is a defined action and new state shown in the state transition diagram, then we populate those here. If there is no such action and new state, then we show it as undefined. Okay. Now, at that point, we can go have a conversation with the system designers, requirements engineering people, business analysts, architects, what have you, and say, hey, what is supposed to happen in this undefined situation? Now, maybe they say, well, we have a default event handler set up such that if any event occurs, it's not expected based on the state, we pop up an error message that says, you know, your session has become confused, please go back to the home state, or something like that, right? The important thing is to know that there is some defined action, and then you could populate this table based on that defined action, right? If the response is, oh, well, don't worry about that, that can't happen, then, you know, as testers, you know what to do next. You try to make it happen, right? You don't just accept, oh, yeah, sure, that won't happen, because it will happen, right? Someone will figure out a way to make it happen. So brute force, you would go through and you would define test cases to try to force these things to happen. Okay, now, you might or might not be able to actually do it, but you would try to force it to happen. So that would lead us to this derivation of tests to achieve row cover again, we have a set of tests that we created for state transition, based on the state transition diagram for the state transition cover, including the start-stop rule. Okay, so we've got a place to start here. Then what we do, construct the table, check that the existing tests cover all the defined rows, and they definitely should. If they don't, then you didn't define the table correctly, or you didn't define your tests correctly, one or two. Something's wrong. So don't leave step 2 until you confirm that the state transition diagram tests cover all the defined rows in the state transition table. Then you wanted to take a test that visits one of the states that has an undefined row in the table. Copy that test, modify it to try to force the undefined event condition combination of that state. That covers the row. And then repeat steps 3 and 4 until all the rows have been covered. So this is a fairly simple process, but as you can imagine, with 66 rows, in this particular example, it could lead to a lot of tests. This is why it's very nice if the developers have actually thought about this, to find a default handler, because it's going to make your job a lot easier. So to take an example here, we see an existing test. Okay, browsing, add to cart, selection dialog, checkout, login dialog, login good, purchase dialog, and abandon. So this is abandoning from the purchase dialog box, right? Purchase dialog state. So modified test that we can create here is try to force a continue shopping event while in the browsing state, which is not defined. And then see if you can actually continue on to the purchase dialog and then abandon without it doing something weird. And the thing you have to worry about is just because nothing weird happens when you force the undefined event to occur doesn't mean that you haven't set into motion a sequence of events that will result in weirdness later, right? So you have to carry the test through to its logical conclusion to verify that that the right thing has indeed happened. In fact, we've just now seen an example of this where we tried to change the state of the timeout and on the screen, and it didn't change, so well timed. Here's another example, another modified test from the browsing state. Here we see we're going to try to force a checkout to occur, and then there are a number of other ones where we can try to force undefined events to occur while in a browsing state. Okay, now, one of the things that makes it somewhat time-consuming potentially is you don't want to try to cover multiple undefined event condition combinations in any one test, because if something weird happens, then you can't really say why. You don't know that the system's going to remain in any sense testable after you've done something that's undefined, right? And if you're really paranoid about this, of course, you want to actually reboot between each of the tests. For a typical application, that's probably overkill. You'd probably find to just exit the application and go back in, right? Now, the best possible situation here is that these undefined event or event condition combinations are simply ignored, or better yet, rejected with some sort of intelligent error message. Now, there can be security reasons why it might be better to ignore than to reject with an error message, right? If the rejection with an error message is going to give somebody a hint about how to subvert a security feature, then usually you want to simply ignore that, right, and not provide any hints. So for example, when you enter a valid username but an invalid password, most systems will not come back and say that is not a valid password for that username, because that would, in essence, confirm the validity of the username and be providing helpful information to someone who might be trying to break in, right?